Hey everyone, my name is Push. Today I will be presenting accelerating IR response with distributed graph technology. So let's begin. So quick disclaimer before we go further in the talk. So content presented here is based on my personal experience and publicly available information. It has not been officially approved and endorsed by any organization. Let's discuss the limitations of the traditional IR systems. I categorize the problem in four subcategories: the data fragmentation, time synchronization issues, relationship blindness, and manual correlation overload. So data fragmentation. So in today's world, we have a lot of systems producing data, and it's very hard to connect the data across those disconnected systems, which hinders the time aggregation and correlation. The next is time synchronization. So all the systems generate events according to a time which is relevant to them. So we don't get accurate forensic timeline when we want to reconstruct everything. Relationship blindness, traditional model fail to capture a complex relationship between various entities. The last one is manual correlation. I've seen a lot of SREs on the front engineers looking at dashboards, which is a time consuming process to events that happened over the time. So these inherent limitations result in fundamental problems in the security systems, which are leading to extended detection system resolution time and incomplete investigation and increased operational cost. So we are trying to address all these issues. So now graph technology for incident response. So graphs can transform the all the entities in a relationship model, which can help us to debug the issue better. So it can categorize the issue among nodes, edges, and properties. So nodes are the user's machine IP addresses, processes. Edges can be like relationship exist, created, communicated with. Properties can be contextual information like timestamps, severity, and classifications. So these structure enable us relationship-based investigation, which follow the natural progression of security incident across the system boundaries. So in graph database, we can build this unified semantic layer across all siloed data sources, enabling the comprehensive analysis. For example, we can put all the data from network application, endpoint, cloud, identity indexes in one big giant like dashboard, and we can query across. So now whatever problems we've discussed, Spanner Graph is a natural fit for that. There are a lot of SaaS applications available in the market, but with Spanner Graph, we just use Graph for your day-to-day OLTP workload and also for analysis workload and build a huge graph. So Spanner Graph is a globally distributed graph database extending Spanner's capability for precise, reliable analysis of massive distributed datasets. So for incident response, Panagraph offers global consistency. All it ensures like all the data is consistent and immediately available across all regions. The truth is it enables a precise, globally synchronized timelines, eliminate the timestamp discrepancies for accurate forensic reconstruction. Relationship model, we can build the massive graph by edges and connect those edges across multiple nodes. Scalability and reliability. So Spanner inherently has horizontal scalability for petabytes of data with automatic sharding and replication for high availability. By combining these attributes, Spanner Graph transforms the fragmented data into cohesive, globally consistent relationship-based database, which can accelerate investigation and strengthen security posture. We will discuss two specific things which are very interesting. First is true time, other is the relationship model. True time is a very fundamental construct in this panel, which provides solution to various problems. Like we will get globally consistent timestamps across different systems. We get bounded uncertainty. So we have a maximum skew that can happen between various events. Causal consistency. It guarantees that events are ordered across all regions, preventing a true sequence of the actions. A relationship model. So as we have discussed earlier, with a relationship model can be defined by your nodes, edges, and properties. So what this get us? So this can help us to identify few of the early things in the to the incident responders, which we usually look for. First, it will identify the blast radius by traversing the connection from the breach point of the affected asset. So it can do the lateral movement patterns across traverse system, revealing the attacker's path in detail. We can also discover hidden relationships across unrelated events, connecting the dots which traditional tools miss. We can build a comprehensive attack timelines with perfect sequencing and thanks to the temporal consistent and causal mapping. So the holistic view empowers the incident responders to move beyond fragmented, alert-driven system and leading to faster, accurate incident response and minimizing the business impact. I'll briefly touch on the query capabilities that Spanner Graph has. So we can do path analysis, find all the possible connections between compromised assets. We can do pattern matching. We can do take centrally available measures like critical assets and identify the choke points. We can do the community detection, like group of related events to identify the campaign scope. So these kind of scenarios can be easily covered by Spanner Graph capabilities. A very brief slide on the implementation if someone wants to onboard, like what they need to do. So I categorize that in four or five, I would say five different categories. So the first one is collection. We need to collect the data from all the sources. Then we need to normalize those. And find, after that, we need to fit that in a graph model. And once we fit that in graph model, Spanner storage is a natural fit for that. And after that, we can just investigate by using the Spanner query model. Three technical challenges which I have listed if someone wants to design the application. So the first one is schema design. So we need to see how we can balance between various entities and relations for getting the good performance. The second is ingestion timeline. So we need to see whether we are doing the real time or the batch processing, how we are handling out of order events, how we are enriching the data across this. So this we need to ensure like all the queries are responding within the threshold. For that, we might need some of the tunables in query, either better planning or some caching, or we need to balance out the response time with the data that we're fetching. Key takeaways. Spanner transforms a IR by providing few of the capabilities which are unique to the system. The first one is it provides a unified time synchronized view across all security events. So we can trace the attack progression through complex multi-hop relations. It provides the precise time coordination that eliminates the timestamp discrepancies. So it helps us to build a relationship model that reveals the full scope of compromise. By implementing this approach, organization can achieve faster. Thank you.